GATE 2021 Mechanical Metallurgy. For uniaxial tensile stress strain behavior of a polycrystalline aluminum, which one of the following statement is true? Here it is given, true strain is always higher than engineering stress. At ultimate tensile stress on true stress strain curve is d sigma by d epsilon is 0. The resilience is the area under elastic region of engineering stress strain curve. The maximum true stress does not correspond to maximum load. So, if you'll consider sigma versus E, this is engineering curve and this is true stress. So true stress is always higher than engineering stress. So this is true. At ultimate tensile stress point, the engineering stress strain curve will have d sigma by d epsilon is 0. So the ultimate tensile stress is not for true stress strain. So this is wrong. The resilience is the area under elastic region of engineering stress strain curve. So this is resilience. The total area under this curve is toughness. So this is right. The maximum true stress does not correspond to maximum load. Yes, the maximum engineering stress corresponds to maximum load. So maximum true stress does not correspond to maximum load. This is right. So answer is B. Which one of the following is false for creep deformation? The minimum creep rate is obtained in primary stage. No, if you'll see the creep rate curve, epsilon t with respect to time, it will be like this. So the minimum creep rate is steady creep rate. It decreases here and then it increases suddenly. So the minimum creep rate is not obtained from stage 1. And the creep resistance decreases with decrease in grain size. No, the creep resistance is opposite in direction. The smaller is the grain size, more is a creep deformation which will happen. So creep resistance will be with higher grain size. So the cobalt creep occurs via grain boundary diffusion. Yes, cobalt creep occurs along the grain boundaries. So Nebula creep occurs via lattice diffusion. This is right. So, and again, if I wanted to mention here, the minimum creep rate occurs at along stage 2, which is secondary stage. The creep resistance decreases with grain size. The diffusion path decreases, so the creep resistance increases. The cobalt creep occurs via grain boundary. So, answer is A. A body is subjected to a state of stress given stress tensor. Now, 50, 100, 200, 0. So, if yielding is predicted by Tresca criteria, the uniaxial yield strength the body should be equal to. Okay, according to Tresca criteria, T max is given by, in a stress tensor, all the shear stresses are 0, if you'll observe here. So the tensile stresses are the principal stresses itself. So tau max equal to sigma 1 minus sigma 3 by 2, where it is equal to sigma y by 2. Oh, sorry, this is by 2. And this is maximum, this is minimum. So the maximum stress here is 200 and minimum is 50. So it is 200 minus 50 by 2 is equal to sigma y by 2. 2 gets cancelled. So sigma y equal to 150. So it is 150 ampere. In the absence of an external stress, which one of the following statements is related to interaction of point defect and dislocation defect? Okay. So now you have to see, like, this is a point defect and the dislocation. Okay, this is a point defect. Let's consider like this. Okay, it depends on epsilon, sine theta, and some other factors also. Here, you see this as volumetric strain, where if it is a smaller interstitial defect, it will be the volumetric strain will be negative. If it is a substitutional element, the volumetric state will be greater than 0. Or for a larger substitutional element or for a larger dissolving element, it will be greater than 0. So for an oversized solute atom would prefer migrate below the slip plane of a edge dislocation. This is true because here it is greater than 0, and sine theta, if it is greater than 0, the total interaction energy is greater than 0. So it will try to be in the below plane. The bigger atom try to be in the below plane because this is positive, this is negative. When it is positive, it tries to negative, it tries to attract, positive, it tries to repel. So in this case, it tries to stay here. A spherically symmetric point defect can interact with both hydrostatic and shear stress fields of a dislocation. No, a spherically point defect can interact with a hydrostatic stress field only. The hydrostatic stress field shown is symmetric in nature. So since a screw dislocation has only shear stresses, it will not interact with the spherically symmetric strain fields of a point defect. A point defect can locally modify the elastic modulus and thereby change their interaction energy. This is what I call this mu is interaction energy. So point defect is locally changing and trying to be stable here. So this is also true. Vacancies are attracted towards the compressive region of dislocation region. So here it will be compressive and here it will be tensile region. So the smaller atoms I told you, it tries to be on the above plane. So this is also true. So the only answer is B. A single crystal aluminum sample is subjected to uniaxial tension along 112 direction. If applied tensile stress is 100 ampere and the critical result shear stress is 25 ampere, which one of the following slip systems will be activated? Okay. Now, if you see option A, you have to find the Schmidt factor M is equal to cos theta cos lambda. So first cos theta, this is the direction and this is the plane. So it is 112 into 1 bar 0 1 to 111. So this and this. The angle is M is equal to uh, is 1 bar plus 0 plus 2 by root 6 into root 2 into 1 plus 0 plus 2 by root 6 into root 3. This is not equal to 0. So for second option B, it is 1 bar plus 1 by uh, root 6 into root 2. This is equal to 0 because this is anyhow 0. So C, it is 1 plus 1, 1 plus 0 plus 1 by root 2 into root 6 into 1 plus 1 plus 2 bar by root 6 into root 3. So this is 0, so everything is 0. So D, if you see, 0 plus 1 plus 2 by root 6 into root 2 into 1 plus 1 plus 2 bar by root 6 into root 3. So this is 0. So this is 0. The only option A is not 0. Here, what I mean is when the tau CRSS is not 0, the slip systems will be activated. So in all the other cases, it is 0 and it is not activated. So two dislocations lie parallel to each other such that parallel to each other to z-axis lying in xz plane as shown in the figure. The glide force which is exerted by the edge dislocation on the screw dislocation is. So here everything is given. Tau xy is gb by 2 pi into 1 minus nu x into x square minus y square s square plus y square whole square. Okay. So here we know force is equal to tau into Berger vector into x. So F is equal to GB by 2 pi into 1 minus nu into x into x square minus y square by x square plus y square whole square into b bar into x. Okay, here in this plane, y is 0. Okay, y is 0. And next, f is equal to 28 into 10 power 9 into 0.29 into 10 power minus 9 whole square by 2 pi into 1 minus 0.3, which is equal to f is equal to 0.53 into 10 power minus 9 Newton. If you'll round it off, it is 0 Newton. So the force, the glide force by dislocation on screw dislocation is 0. In a material of shear stress 100 MPa is required to bow a dislocation, the line between the precipitate spacing 0.2 micrometers. So this is 0.2 micrometers. The dislocation is coming and getting impinged by this. Okay. Now it tries to bow around each other. So it becomes like this. And then it becomes completely spherical in nature. Then the tau is equal to GB by L or GB by 2 pi R. So shear stress is given as 100 and shear modulus is given as nothing. So the Berger vector, the spacing is 0.2. The spacing, the increase to 0.5 micrometer. So here it is tau 1 L1 equal to tau 2 L2. So when 100, it is 0.2. Then when it is 0.5, what is tau 2? They have asked. So tau 2 is equal to 40 ampere. Okay. Now, the metal plate in a plane stress condition, plane strain condition is so sigma zz epsilon zz is 0 and sigma xx and sigma yy are equal but not equal to 0 and shear stresses tau xy, tau xz, tau yz is 0. The Poisson's ratio is 0.3. Then the ratio of sigma zz by sigma xx is. Here you know epsilon z is 0. We know epsilon z is 1 by sigma z minus Poisson's ratio into sigma xx plus sigma yy. And sigma zz is given as mu of sigma xx and xy are equal, so you can write this as 2 sigma xx. So here it is asked as sigma zz by sigma xx is 2 into the Poisson's ratio is 0.3, so it is 0.6. An infinite plate has a central through thickness crack length of 80 pi mm. The maximum applied stress in MPa that the plate can sustain in the model mode 1 is. So you know mode 1 here, fracture toughness through mode 1 is 20 MPa meter per 1 by 2. We know K1C is equal to sigma root pi a and the central crack length is given as, so 2a is given as 80 by pi. So a is equal to 40 by pi. So K1C is 20, sorry, 20, which is equal to sigma into root over pi into 40 by pi. So sigma is equal to 20 by root 40 into 10 power minus 3 as it is given in millimeters is equal to 100 ampere. Because this becomes 400, so 0.04, so it becomes 0.2. So 200 by 0.2 is 100. Thank you.